Good morning once again, everyone. We are very sorry about the on and off. It's just due to network issues and some glitch with YouTube itself. We are so sorry, but we are going to be starting again, and we hope that everything will go smoothly. And thank you for still being here. I mean, it means a lot to Geoinfotech. Thank you. So today's webinar, as we may already know, we are taking the role of drone data in mining and construction. Once again, my name is Precious, and I'm honored to be your host for this webinar, proudly organized by Geoinfotech. We're truly excited to have you join us from different parts of the country and possibly beyond as we explore how drone technology is reshaping two of the world's most critical sectors, the mining and construction. Over the next 2 hours, we are going to dive into how drones are not only improving safety and efficiency on work sites, but also improving surveying, inspection, data collection, and decision making in ways we never imagined a decade ago. We are privileged to have two distinguished speakers with us today, and we'll be hearing from our managing director, Mr. Makinde Temitope, who is a visionary leader, a strong advocate for the integration of emerging technologies in field operations. Following that, we are going to have an in-depth season with our main speaker, who is the lead drone consultant in Geoinfotech, in person of Mr. Famuyiwa. He'll be taking us through how drone data can be used in construction. And also, we also thank you all, our returning attendees, for your continued engagement. If this is your first time with us in Geoinfotech, we warmly welcome you, and we hope that today leaves you inspired and informed. Also, at the end of every session, I'm sure you have questions. You can drop your question in the chat box, and we will attend to them before the end of the webinar. Thank you very much. And so we'll be getting started with Mr. Makinde Temitope as he delivers the opening address. We can have you now, sir, Mr. Temitope.
All right, thank you for joining once again. Sorry for the glitch we had last time. My name is Makinde Temitope. We're putting you through Geoinfotech, and I also want to appreciate you for coming live with us here on YouTube. So what we'll be diving into is that about drone data in the mining sector and also in the construction sector. As we all know, Geoinfotech Resources Limited, we are in Nigeria, Lagos, and Abuja. All right. And one of our core responsibilities is providing quality services in every of our sector. And we also offer services in different sectors, like in the drone surveying sector, in the mining sector, in the agricultural sector, in the real estate sector, urban planning, all different sectors. And I'll just use this opportunity to introduce Geoinfotech to you as an industry leader in this sector, in the geospatial and drone technology deployment. Okay, we provide state-of-the-art solutions with drone technology, geodatabase for several agencies, satellite data acquisition, and modeling of drone data, bathymetry data sets. And we provide broad range of high-level geographic information system and remote sensing services. Some of our prominent and prestigious clients are here with us also. I believe we will also have you with us and get to know more about you, and you get to know more about us in this webinar. In this webinar, we'll be diving into a lot of stuff that you're going to be learning. I'm going to put you through some of the things you're going to learn from us in this sector. All right. And as we all know, the mining sector regarding to drone is alarming, and a lot of people are using this to save time, to save costs, and also get the result they need. That quality result, that precise results they need is what we focus on at Geoinfotech. So in this webinar, we'll be going into in-depth understanding of UAV, aerospace regulation, and data acquisition. And also the different payloads integration, including cameras, remote sensing, and thermal imaging. There are a lot of geophysics, and also people are integrating aeromagnetic, integrating different payloads to drone. So far it can fly and give quality data capture. That's all what they need at times. And we'll be diving into data acquisition for surveying and construction and also mining, and how you can get this data and transform it into mining sector to get mining workflow results. Okay, and we have real world case use where we'll be introducing you to some of our projects, and how we'll be able to capture these data sets, how we'll be able to analyze and process these data sets, and the results we get from this to our clients. And we'll be introducing it to a lot of tools. You can see behind me, we have a lot of tools where we introduce to this mining sector. And these same tools can also be useful in this construction sector. All right, they save time a lot, and it's also safe for you when using these tools in terms of safety and in terms of quality assurance. And also, there are a lot of opportunities we'll be bringing into this webinar that can also help you regarding to those that are going into this business in mining and construction sector. All right, my name again is Makinde Temitope, and I will be your speaker for today's webinar. All right, so stay tuned.
All right, thank you very much for that opening address, Mr. Temitope. We'll be moving on to the presentation by Mr. Famuyiwa, and he's going to be walking us through the role of drone data in construction. Like I said before, he is our drone consultant, our lead drone consultant in Geoinfotech. We can have you now, sir, Mr. Famuyiwa.
Hi, good morning. We had a slight glitch earlier on, but we're back fully live now. And just so you know, this webinar is being recorded. So if you have anything that was missed, or you joined us late, you could always, or you have questions that are not answered at the end of the webinar, you could always get in touch with Geoinfotech, and they'll probably do a good job in answering all the questions you have. Anyway, so moving right along, my thing now is, as Mr. Tokwe had mentioned, we're going to be delving a lot into data acquisition, okay, or analyzing the data. My thing is okay, fine. You're going to analyze data. How'd you get the data to begin with? And that's where I come in. Once again, my name is Mr. Yomi Famuyiwa. I'm a retired senior computer network engineer for the Los Angeles County Office of Education. Retired now, and back when I was in the US, I was using drones as a hobby. But now that I've passed my USA FAA Part 107 exam. That's basically, I am now certified. I'm a certified drone pilot, so I can fly these drones commercially. And so that's basically what I've been working with Geoinfotech for a while now. And without further ado, let me start getting into my slide presentation. There's just so much to cover, so I'm basically going to try and break it down as best I can and not delve too much on one topic or the other. Again, you can always come back later on and ask us questions or get in touch with Geoinfotech, and they will probably answer all your questions. Stand by. Okay, so basically here we have a slide of someone sitting in his office with a cup of coffee and what looks like a pastry. So what if you could inspect your entire site without stepping foot on it? I mean, that's every investor's dream, or every site manager's dream. Sit back, the drone flight is being sent to you live, and you can just basically see what's going on site. Okay, so what kind of challenges do we face in construction in Nigeria? Very limited visibility of the site progress. There are always delays. Most times there are delays and cost overruns. There's safety risks on site. There's difficulty tracking material usage, right? Drones can help fix all this, and we'll be going over a few of those challenges and see where the drones can actually come in and help out. Okay, drones are basically your eyes in the sky. And what are drones? Drones are also known as UAVs. They're unmanned aerial vehicles. They capture high resolution images and videos. They fly autonomously or manually. Now, what I mean by autonomously is like you sit in your office, you get your, I'll be going over some of the apps that you're going to use to for all these drone flights, something like Drone Deploy or Pix 4D. Sit in your office, map your mission, preview it before you get to the site. Get to the site, put your drone up in the air, and the drone will automatically or autonomously fly the mission for you. Okay. But having said that, it's also very important that you manually know how to fly a drone, just in case when you get to the site, things change and your autonomous mission plan that was taking place missed a few shots. So while you're on site, you can go back and take shots or capture shots of those images that were missed. That's where the manual thing comes into play. Okay, drones are equipped with GPS and high sensitive sensors. Okay, drones are basically your eyes in the sky. I don't know how else you can get a view of drones, get a view from that high out. Okay, where do drones fit in the construction site life cycle? You can have daily, weekly, and monthly site monitoring. You can do topographic surveys. You can take progress photos and generate 3D models. You can do site surveying and planning. Um, you can monitor the progress on the site as construction goes on. You could monitor that progress. You could do material management. What do I mean by material management? Basically, on the site, one of your contractors says he delivered 10 truckloads of gravel or sand, but he only delivered 9, or each truck wasn't full. It was like 90% full. Well, the drone is up there. You just have to make sure that when he delivers the stuff, the gravel or the sand, the drone's taking a picture of what's being delivered. You could also take stockpiles after he's dropped off the commodity on the site. You could also do kind of centimeter precision measurements of, okay, this pile here yesterday was what, 2 tons worth of material. Today, nothing's being used. It's now 1.5. You can do those kind of material, you know, watch what's going on the site. Structural inspections. This is very important. I'm sure a lot of us have heard over the last couple of months or the last few months in Nigeria that there are a lot of buildings collapsing. Why is this? And then you turn around, architect blames structural engineer blames architect, and blah, blah, blah. It goes on. But truth be told, if you have a drone up there and while you're building, the drone is basically taking pictures of how the structure looks like. The structural engineer can turn around and say, hey, listen, I followed the code. This is what I did. Because to be honest with you, if it's a really, really large project, apart from loss of life, there could be lawsuits. There could be big bank loans that need to be repaid. And structural engineer shows the bank or shows the investor, this is the work I did. So they're covered. And it also covers the owner of the project, and list goes on. You could also use all the monitoring, the drone shots and everything for your marketing purposes. We'll show you slides of images that have been captured, and you can use this for your marketing. And you could also use the shots and the deliverables to show the investors, okay, we said in 2 weeks' time we're going to get to stage B of the plan or of the building or whatever, and you could show the investor, yes, we're on time. And if you're not on time, you could always explain to the investor why you're not on time. Before you could also one important thing that you could do is take the site progress monitoring. So as you can see on the slide, this is a drone taking a shot of looks like the foundation has been laid, and this is a before picture that you can show your team or the investor or whoever needs to see what's going on site. You could also use the what you call it, the pictures and put them side to side, showing the before and where you're at the construction stage. You know, it comes in very handy. Okay, 2 weeks ago, you had the left half of the construction. 2 weeks later, you're here. So it gives everybody peace of mind that yes, site manager or architect or structural engineer is following through on what they promised. Next one, why use drones in construction? Key benefits: speed, safety, and accuracy. Okay, you get faster and more accurate surveys, um, improved safety monitoring, visual reporting for clients, lower labor and inspection costs. Very important for investors. The lower, if you can lower your labor cost and your inspection costs, so be it. Now, I know for a fact that sometimes with these really large projects, maybe the owner of the building hasn't come out of pocket himself. In other words, maybe he's gone to a bank to get a loan. Now, most times, maybe not in Nigeria so much, the money is released in tranches. In other words, 1 week you say you're going to do X, Y, Z on the site. They will not release another money to you until you prove that you've completed that first part. So that's where the inspection comes in, and by having a drone, it's practically very difficult for a human being to get into some of these inaccessible areas of a site, and pretty dangerous. Next slide. Benefits of drone surveys. I'm just going to read through the list. They're pretty self-explanatory what they mean. They are completed by professional building surveyors who are trained in building pathology. They capture detailed imagery of otherwise inaccessible locations. You get closer to the survey target, which improves the quality and density of scan. Completion is faster due to ease of access. They reduce health and safety risks. Very important. No plant shutdowns are required for a drone survey. Most of the drones, although sometimes you have to get permission from the client and let them know you're going to be flying your drone over people. But the law does say that as long as you don't have a sustained flight over people, you're good to go. And you could do that while people are working, as long as they give you permission to do that and let them know what you're doing. They provide a more thorough overview of a site. Don't need any explanation there. They are more cost effective than traditional surveys, definitely. Next slide shows speed. On the left-hand side, we see a picture of a drone going around a building. Okay. The bottom of that slide, you have the operator with a remote controller. Whatever he's looking at, he's watching exactly what the drone is doing. Okay. Uh, he uses the controller to guide the drone if he's flying manually. I mean, autonomously. If he's flying manually, that's when he will take more control of whatever the drone is doing. And then the drone in time is feeding him real-time data. Okay, he can see exactly what the drone is doing. On the right hand side, basically, is looking up from the sky or from a drone, what's going on a site. Here we go. Safety, big issue. Now, on most of these sites, you've got to have your hard hat on, got to be wearing one of these funny looking jackets. Got to have your safety boots on because, God forbid, there could be accidents on site. And if you have a drone up there taking sites as the construction goes on, and you can see on the right hand side, everybody that's on site has a hard hat on, which is very important. If someone falls or a brick falls or falls on someone, at least you're covered in the sense that oh, all my workers are well equipped. They're covered. Wearing the right safety gear. Moving right along, we have accuracy. Now, this is where Geoinfotech excels. On the left-hand side, you basically have one of these GNSS. What's GNSS? Global Navigation Satellite System. Basically, at the bottom of this little gadget here is a marker. You put the marker down, put this GNS gadget on top of it, and it will give you real-time coordinates, precise coordinates of exactly what's going on. Okay. On the right-hand side, if you can look real close, you can see where all the GCPs, which is ground control points, have been placed. So basically, when you finish, your drone should be able to see these GCPs, and there, that way you can get centimeter level accuracy of what's going on site. Now, why do you need centimeter level accuracy? You can take measurements of that. Your surveyors might need measurements of, okay, what's the acreage of, or what's the size of a plot. You could also use this to measure each little bit that's going on the site. You can measure road widths, all kinds of stuff. If you look on the right, it looks like two ponds there. You can actually do measurements and let your architect or whoever's doing your designing know, well, that pond right there is going to affect the design of this site. So your architect can take that into consideration. Okay. What's next? Types of data collected. Okay. On the background here, Geoinfotech just finished a big project in Niger State. I'm sure a lot of you that live in Nigeria are familiar with what happened, the disaster from the floods in Niger State. So they went out there and they took aerial photos, and this is basically what they came up with. So again, it all depends on what your client is requesting. Some clients might just want, oh, just give me an aerial view of what's going on. I don't want anything too fancy, blah, blah, blah. But most people that Geoinfotech deal with, they want precise maps. What are precise maps or precise deliverables? 3D models or elevation maps. orthomosaic maps, digital surface models, which are called DSM, digital. Oh, I think I made a wrong spelling there. But anyways, it should say digital terrain map, DTM. Okay. Um, there we are. Now, this is what they did on Niger State. They took all these maps, put it into the right processing software, came up with this that is being is going to be submitted to the authorities so that when they're planning in the future, a lot of homes got damaged, a lot of homes and lives were lost. So the authorities or whoever's going to develop this place can now take these maps and say, okay, water flows this way, this is where we're going to do our design, or this is how we're going to design the site in the future. Okay, these are more maps that they did. As you can see on the left, it says drainage channels. So basically, the site surveyors or the architects could know how to design along these lines, bearing in mind that there's all these drainage channels that are either working or the water needs to be channeled some other way. Okay. Mostly contour maps are for surveyors. Okay, so it just shows different elevations. Again, what Geoinfotech did on the right-hand side is they showed basically all the affected, all the buildings that were affected by the floods. More maps. Okay, this is a point cloud map. It's basically for surveyors, civil engineers, and architects. Okay. This is a 3D model. So what's a 3D model? It's basically flying your drone at an angle. So it can now get the facades of all the buildings, and the when you stitch the photos together, you could see the sides of the buildings as opposed to this, which is an orthomosaic map. So what's an orthomosaic map? It's basically you using your drone and pointing your camera straight down. Some softwares will say 0 degrees, some say 90 degrees, but basically it's pointing your camera on your drone camera right down, so it gets, you don't see the sides of the building. It's just taking everything from straight above. If you look at the bottom corner, no, let's go to the top. The top part of the slide shows the mission plan. Again, I think I've spoken to you what a mission plan is. Okay, and the bottom right shows where all the photos were taken. Those little blue dots are where images were captured by the drone. At the end of the day, you're going to get, depending on how detailed your client wants your mosaic map to be, you're going to get several photos like the ones on the left. The ones Geoinfotech did the couple of weeks ago for the Niger State was that they did in excess of 400 photos, and all those photos had to be stitched together, and that's how they were able to come up with their maps. Okay, moving right along. Technology behind the scene: drones, survey equipment, and software. So basically, I don't know if you're getting into the business, if you're already in the business, or you're looking to talk to Geoinfotech and see how they can assist you with your project. But if you're just starting out, I'm not gonna sugarcoat anything and tell you that it's pretty cheap. Of course, you can buy one of those cheap drones, but the cheap drone's gonna do the job for you. I do not think so. So right here at Geoinfotech, they have the top of the line drones. Um, and basically they use either drone deploy, Pix 4D, and ArcGIS. To the top right hand corner, that shows one of those GNSS modules that you use uh, to get coordinates, exact centimeter level precision, and that's why you need the coordinates. So basically, most of the drones, all the drones that we use here at Geoinfotech, they're also RTK equipped. RTK is real-time kinematic. It's basically you taking exact pictures, not exact pictures, detailed pictures of what's going on in sight. Now, the experts say you should always combine your RTK with your GCPs, which is the ground control points. That's the best way to get uh, um, your precision or centimeter precision maps. Okay. So again, don't let this put you off. Geoinfotech is here for you, and they will assist you or guide you if you want. If you're just starting off, and if you can't afford to put all this stuff together, they're here for you also. Moving right along. Drones in construction, challenges to the options. So basically, apart from you purchasing all this equipment, there are also challenges with the safety and regulations in Nigeria. Okay. And we just touched on this initial startup cost of equipment and software that could run you a pretty decent amount of money. But it pays off in the end. One or two of these jobs, and the equipment is practically paid for itself. Okay. Now, like I told you before, I am FAA certified, which is the Federal Aviation Authority in the US. Nigeria has the NCAA that you have to go through to get registered. Oh, and by the way, we run into clients at Geoinfotech that insist that the pilots are Part 107 certified. So we can cover you that way. Now, there are also drone zones and no-fly areas, especially if you intend your job site is near an airport, military base, those kind of important areas. You've got to get permission from the NCAA to fly in those areas. Insurance and site approvals. Most times, a lot of people build in Nigeria and they don't have insurance for their workers or loss of equipment, blah, blah, blah. At Geoinfotech, we're well insured for people, for the drone pilots, and they will get site approvals before commencing work from both the authorities and obviously the clients. And sometimes you might even need to get approvals from neighbors if you're going to be flying over property that's not yours. Just maybe you want to show the site to an architect and you want to show him, oh, this is the kind of designs that are in the neighborhood. That's where you might have to get site approvals from the neighbors. Okay. Now, most importantly, for more information about flying drones in Nigeria, visit those links at the bottom. They will give you detailed explanation about the laws. So if you intend to get registered with NCAA, it's I will not lie to you, it's a tedious process. Geoinfotech can help you there. They can hold your hand and assist you in getting registered if you are intending to fly your drones yourself. Okay. Well, call to action, partnership opportunities. So let's assume you're a client and you come to me and say, "Oh, I want this. I need maps of the following, of some sites out there." So basically, the client will request for the flight. Flight is conducted. Geoinfotech will take all those photos that have been shot, stitch them together in either Pix4D or drone deploy, and then deliver the data, which is the deliverables, to the client. And we will help you analyze the data if need be. So that's basically Geoinfotech will help take your project or site to new heights. Yeah. Okay, these are just I'm practically rounding up now because I want to keep I don't want to keep going on. I could spend days talking about this stuff, but I've kind of just summarized it. Again, all this stuff that I'm talking about is going to be recorded, and you'll have a chance to review it in your own time. And if you have questions at the end of the session, we'll be more than happy to answer those questions. Plus, you can refer back to the webinar and then follow up. So basically, this this picture here practically doesn't have anything to drones, but just watch. This is a guy on the site, and what is he doing? He's taking notes. Old school guy taking notes. But watch his face at the end of the clip. That doesn't look like somebody that's too happy about what he's doing. I am yet to find a drone pilot that doesn't have a smile on his face, because it's not easy work, but it's enjoyable because you can actually see the fruit of your labor. This guy here, oh no, I won't want him to be my site manager. So moving right along. So basically, we're just showing drone shots of construction sites. Okay. Now, I don't expect all your sites to be this large, but who knows? With Geoinfotech behind you, that's bring them. You can do everything. This is a site from, here you practically see sand or gravel or sand piles. Now, if you're using the GCPs, or you're using the RTK drones with the RTK models on them, you can actually take stockpiles of all that stuff there. So your site manager says, "Oh man, we're running out of sand, or we used up half of the sand that we need for the site." You can always go back to some of the progress reports or some of the progress pictures that were taken when this stuff was delivered. 1 week later, there's only 50% left. What exactly did you do with the 50% of the stuff that you claim you used? Those kind of questions. So that's basically showing what's on site, the pre-construction. They've already started laying out some slabs here. This is another big one. I don't know if you could imagine monitoring a site like this, having individuals I don't know how you would do it. Well, you might have to, if your company is rich enough, get a helicopter to take these shots. But basically, with drones, you could do anything. Okay, it's basically zooming in, and going around and showing you what's going on. Isn't that a beautiful shot of what these drones do? Here also, you can see what's going on. Oh, by the way, we're taking shots of the exteriors of these construction sites. If you need to see what's going on the inside, we could also do that at Geoinfotech. lots of drone pilots only take shots of the outside of the building. We can also take shots of the inside, so you can make sure that the pillars or columns or whatever structural stuff you out there is placed right, it's the right width, that kind of stuff. Okay. So you can basically see, okay, all the AC units or air units where they placed right. Okay, so that's basically it. We're coming to an end, so please bear with me for a couple more minutes and we'll be done with my presentation. Okay. Okay. Basically, this is a site, and I left the audio on this one because you hear this. Hold on a second. Trying to get this. You hear those clicking sounds. That's the drone taking pictures at precisely predetermined spots on the site. If you look at the bottom left corner, right, that's one of those mission maps that you've already pre-planned. So basically, you get out to the site, put the drone in the air, and watch what happens at the bottom left. The drone is taking pictures at maybe every 1 second. Watch what happens now. As the drone turns, you see it's still following the pre-planned map and it's taking pictures along the way. Now, I'm not going to finish all this site, but as you can see, in this particular software, it's showing you how much of the map, pre-planned map, it's done. Right now, it's at 57, it's at 58%. And so basically, you can control everything that's going on in your data capture software. Okay, so I think I fast forwarded it a bit because I didn't want to bore you with this, taking you through the whole 100%. We're 66, it should be coming to a closing. So basically, look around the screen and you can see all the settings that are going on that you preset on the drone. And as the drone is moving, it's taking more pictures. I basically take my pictures every 2 seconds, but it's basically up to you. If you want to create 1,000 photos, that's up to you, you know. Yeah, I'm going to be rounding off in a minute, so I'm going to fast forward this a bit. We're almost done. We're almost there. It's coming to a close. We're at 95%. And at the end of the mission, let's see what happens at the end of the mission. 97, 98, 99. It's going to say something. There you go. Here is a site in California that was damaged by earthquake. They want to rebuild, and at the back of this collapsed building, they want to put on some other structure. So basically, your drones can go out there, determine what the damage was, and then report back to the developer of the extent of the damage. Okay, that's right by the ocean. And with that note, I've come to an end of my presentation. So I'm going to hand you over back to Mr. Tokwe, and he will guide you through the rest of the webinar. Over to you, Mr. Tokwe.
All right, thank you so much, Mr. Yomi, and that was really enlightening, and it was really interesting. Coupled with the fact that we saw life experience of drone capture, and also past projects of some of the mining sector, construction sector, and some of the deliverables you get, and procedures on how you approach all these data sets. So I'll be handing over to Mrs. Precious to take over. All right, thank you.
All right, thank you very much for your insightful presentation, uh, Mr. Famiwa. Yeah, he just talked about the brief us on how drone is transforming the construction industry, and I found the part where the was it was displaying a video where the drone was taking videos on a construction site. It's very interesting. Thank you very much, Mr. Famiwa. So, taking us further in this webinar, we'll be having Mr. Temitope Makinde take us on the role of drone data in construction. I'm sorry, in mining. Yeah, in mining. So we can have you now, Mr. Temitope.
All right, thank you so much. I'll be talking about the next part, which is more of the mining sector. You'll notice most of the things we learned previously were a lot of about construction and some of the way so like say the procedures on how you can get data sets, drone data sets for mining as well with construction. Okay, so here we have. Okay.
All right, while we are waiting for starting topic, if you have any question from the concluded role of drone data in construction, please do drop it in the chat box. We will attend to it before the end of the webinar. Thank you for staying with us, and we hope that you enjoy the rest of the season.
All right, sorry for that. So, as you all know, we are going into the mining and also we're going into the construction sector. All right, and my name once again is Makinde Temitope, the lead pilot and GIS analyst at Geoinfotech. Okay, I'll be giving you a bit of what drone is all about. I believe you must have heard a lot about what drone and how we can integrate this drone in the mining and construction sector. And so basically, the professionals do call drones UAV. Some call it UAVs. So I'll be explaining the difference between those things. And some call it drone, all right? Those are the commercial way of operating drones and all of that. But most professionals call it unmanned area vehicle. Okay, this is an aircraft that operates without an onboard pilot in it. Okay, and what differentiates UAV from UAVs? So UAVs is more like the complete setup for a full operation with your drone. All right. Why the UAV is just the drone itself, basically. You understand? It's just a drone. So when you're combining the controller, the software, the drone itself, the antenna for long distance operation, that is UAVs. You can combine other stuff like GPS, radios, and stuff like that. All right. So some terminologies comes in place, and some people they get confused at this point. All right, there are some drones, okay, that are basically differentiated based on their size. All right, now we have small unmanned area vehicle system. They are still drones. All right, we have micro air vehicle. They just differentiate this from the bigger ones. All right, then we have the UAS, okay, and we have the UAS system. That's we also have the UAV. Some call it the unmanned aircraft system. All right, so now this basically is talking about drones for you. All right, it's talking about UAV. It's talking about micro air vehicles. So all these are different terminologies to term this guy. All right, so now you see a lot of professionals differentiating and categorizing this based on their size, based on their operation, and based on how they are being used. Okay, now we have the mini quadcopter. They are also used for specific purpose in the mining sector and also in the construction sector. Now we have the quadcopter drones, we have the payload drones. The payload drones are way bigger than the quadcopter drone. They are called payload drones because they can carry extra payload compared to the quadcopter drones. It doesn't mean that the quadcopter drones are not useful. They are useful in their own space, while the payload drones are useful in their own space. And we have the VTOL drone, the hybrid drones, and the fixed wing drone, and we have the predator drones. Now, there are some operations that are required to be done in-house, while some are required to be done external. That's more like outdoor. All right. So when you do some operation in-house, there are some data sets you need to capture. for safety measures. You want to capture some data sets for other precision data acquisition, for terrain 3D modeling, indoor 3D modeling. You also want to capture data sets for inspection too. You understand? There are a lot of benefits for that with the mini drones and quadcopter drones. But when it comes to outdoor, or let's say external capture, and you also want to get long flights and more sustainability with your flights, you can go with the fixed wing drone or the payload drone. They last longer compared to the other drones. And most importantly, we have the fixed wing drone. They are majorly used for long and shall I say long endurance survey. You want to survey an entire site for like 2 hours, 1 hour, because you notice it has only one rotor, while the quadcopter has about four rotors. So it exhausts the battery faster. You understand? Then we have drone and the sensor. Now, this is where a lot of drones are used for different purposes. All right, a lot of drones are used for different mission. You get. We have the electro-optical camera. This is for high resolution visual, and we have the infrared. This is for its signature. There was a time we were about surveying a site just to detect areas that has high level of its signature. You can't use that with the RGB, with normal photogrammetry, because you need a different payload for that. Then we have the multispectral sensor, although this is very good with agriculture areas, whereby you can check the health of the crop. Okay. Then we have hyperspectral sensor. Hyperspectral sensor is not common. A lot of us don't really see that in markets. Okay, this provides spectral data for mineral identification, and this is some of the things we'll be diving into. All right, and we have LiDAR. LiDAR is best for detailed mapping, especially where we have forested environments. Okay, it's best for detailed mapping so that you can get the bare earth surface while you still have tree and vegetation cover at that area. Okay, and we have synthetic aperture radar. This is majorly for rainfall and vegetation of wide area imaging. They have GNSS. This also is a system embedded with the drone to ensure precision while capturing your data. So you don't have to capture data without precision. So as you're capturing your data with the GNSS receiver, it gives you more accuracy to your data set. Okay, so you're getting good data sets while you're also getting correct precision with your data set. All right. Then we have facial recognition. This is also not common. It's a new tech that is coming up regarding the facial recognition, but this is majorly for security reasons. And we have AI video analytic model. The AI video, we've recently seen it in the Matrix 40. The Matrix 40 is bringing in AI system into the drone, whereby it makes the drone smarter. You understand? A lot of people are doing a lot of AI stuff, and this will actually increase the value of this hardware itself. All right, so I'll be listing a lot of drone data sets that you'll be getting for the mining sector and also in the construction sector. One of the data sets that are, I believe this is one of the common one, is the elevation models. The elevation model is to help you determine the topography of that site, the topography of that site in a model that is in a format of a raster. So it's more like an image format. So we have the DTM, it's the digital terrain model, and the DSM is the digital surface model. The difference between this is that for the DSM, if you are getting elevation model, you are getting elevation of man-made features and also earth features, okay, like trees, the elevation of trees, the elevation of buildings, the elevation of any other object around the site. But terrain model give you bare earth elevation, okay, just elevation of the earth surface. You get excluding the buildings. So in case you want to demolish a lot of buildings there and you don't want to go ahead and waste a lot of money demolishing these areas that are not really necessary, you can do the DTM. It will give you the elevation of the piers, excluding the buildings. So it imagines as if there's no building there. So it gives you the results. While the auto mosaic is just the image of the site. That's the true image in. So the true image is mosaic into a single image. All right, I will give you an example of this as we proceed. All right, then we have the true image of the area. That's more like the map of the entire area. Just assume you have a Google Earth imagery. You see everything within that site, but this one in the form of a drone image. Then we have the 3D points cloud. The 3D points cloud comes in form of points, 1 million points. Each of those points are classified based on their feature. And we have the XYZ. XYZ is one of the common data sets required for the stockpile volume calculation. And this is common with those in the mining sector. Then we have the cut and fill. The cut and fill is very, very important as well. The cut and fill is, imagine you have a survey of an entire land. This is just a fresh land. And you don't want to waste a lot of money buying sand to fill a particular area. Surveying the entire site can give you an idea of areas that are high. You cut from that and fill into the areas that are low. By that, you are managing costs. You understand? Then we have material movement tracking. Because of this, I'm going to fast track this. But I intentionally put the common ones first, then most ones that are not really too common. Then we have blast volume analysis. This is also for safety and also for data accuracy. We have thermal imaging data, multispectral imaging data, hyperspectral. We have chain dictation. Chain dictation is very, very interesting. It's a very, very interesting analysis, especially in the GIS sector, whereby you compare what was there before, even in 2 years' time, 3 years' time, 4 years' time, 5 years' time, you can compare changes of development within those areas and give you analysis to predict what will happen in the future. That's what chain dictation map can do for you. And we have vegetation index map. This is to also understand the crop health of that site. We have infrastructure inspection, crack detection. So this is for those in geology department. Understanding crack also helps you to study kind of minerals that you can possibly get around that area. All right, and we have pit wall stability data. We have road condition reports. We have training dam monitoring. So all of these data sets will be explained in our next slide. All right. So now we have application across mining sector. Now, this is where all those data are being used. Okay, they are being used in the mining sector. Number one is exploration and site planning. Before you go to site, GIS can help you with this, especially with the LiDAR. Okay, and when going to surveying, I'll talk more about the LiDAR. But in exploration and site planning, GIS can help you a lot with this. All right, terrain mapping before mining begins helps you understand the terrain of that site. And if you are going to blast anywhere, it will give you an idea of where it will flow to. Do you understand? Mineral prospecting and with multispectral and thermal sensor. There was a time we did a project for a client in Saudi Arabia. They don't have any idea of where they can find minerals. But with GIS and remote sensing, you know, remote sensing, drone is one of an example, or should I say an hardware for remote sensing. And remote sensing, we all know, is all about you capturing data without you being in physical contact with that particular data. So you just send the drone, it's going out there for you, help you to capture the data set. It's just that the distance is a little bit different from the satellite. All right. But with this, you can understand the terrain of that place, and other layers or other factors can help you understand what kind of minerals you'll be getting in that site before you go in there. All right. This gives you an idea to work with precision. Okay. Then we have planning drill targets based on surface geology. This is also one interesting aspect. Now, the second part we'll be diving into, which is one of the common aspects in the mining and construction, especially in the mining sector, is the surveying and mapping. Drones are being used widely in the surveying and mapping sector, whereby you can create 3D models, you can create 2D models. And with this model, you can understand volume calculation, you can understand cut and fill, you can understand 3D model of the site. Watershed analysis helps you to understand the areas where water will flow to, where water will accumulate before you planning a lot of things. So with this, you can understand the nature of that environment, make advantage with this nature, and also planning accordance. Okay, and you can also track landform changes over time. Now we have stockpile and inventory management. This is one common part within the mining sector. And you can see here we have previous data and previous calculation whereby we brought in past projects, we processed these data sets, analyzed this data set, and also we calculated the volume of this pet coke you can see there. The pet coke is one of the raw material that is commonly used for cement, and also for it's more like should I say waste of petroleum. This is pet coke, and they use this combination with other minerals to get other results. Okay, so you can see here, without you going to the field again, spending hours on time, just these data sets can give you a lot of information. And you can see the analysis calculating the volume of these data sets. Okay, so you can measure stockpile volume accurately and frequently. With this, you can know how much volume is remaining at your in stock. Okay, you can know how much volume is remaining in stock. You can know how much if you've not been cheated. Okay, in the office, you can calculate this with just a simple tool with the Pix 40. All right, you can track inventory level and report and also compare with logistics as well. Then we have the mine operations. So one thing about the mine operations, especially with underground, is it has high intensity for risk. Okay, you can send a drone there to survey the entire mine, and also you can do a 3D model, understand the terrain before going in there. By this, you can monitor the pit walls, ore roads, and bench development. You can also support blast planning and fragmentation analysis. You can also calculate the volume estimation of blast materials and ore movements. Okay, the next thing we have here is stockpile and inventory management. It's related to the one we also did before. You can use this for calculation of different inventories levels and also for auditing reports within the organization. All right. The next one we have here is environmental monitoring and waste management. With this, you can inspect different cracks. You can inspect different seepage, deformation, or can also monitor rehabilitation efforts, vegetation growth according to that site, and also study the water quality within that site. A lot of things this drone can do for you without you being in physical contact with it. So one important thing you will notice about this is that you can get results of about 15 surveyors or 15 GS like field workers on site with using just drone. And anytime you're flying drone, you just need a co-pilot and a person in command. That's the main pilot itself or the visual observer. Okay, you have a visual observer, you have a person in command, that's the pilot itself, and you just have maybe a person manipulating the control. You have three guys capturing detailed information on site, and these sites are transformed into digital copy or digital data set that can be used for multiple results. All right. Then we have infrastructure monitoring. You can monitor infrastructure over time to see development. And with this development, you can also study if there's any mistake. You can go back. So you don't, if you've done anything on site, it has gone like that. Without you monitoring this thing and saving or archiving these data sets, you can't really tell what went before this to this. And understanding this can also track the development level and also predict the level of completion. You understand? So there's an analysis whereby you can study what has happened before, over time, and also understand what will happen next. Okay, based on the duration of timeline of that project, you can identify where damage and maintenance needs to without shutdowns. Okay, and you are working with precision. When we say working with precision, you are being smart at what you do. Okay, the next thing we have is security and surveillance. A lot of people, you can't have eyes everywhere, but with drone, to be honest, you can do a lot of stuff. And with the new Matrix 40, you can fly a drone even if you are not seeing clearly. It can identify if it is an human being standing here, or if it is an animal standing there, or if it's just an object. It identifies that for you. Okay, so with this, we are working smart. You have eyes everywhere. You can survey at one stop, and we have a lot of this. We have a lot of drones at Geoinfotech, a lot of Matrix 40, the Matrix 350, we have the Mavic 3 Enterprise, we have the Thermal, we have the Multispectra, we also have the LiDAR. The LiDAR come in place whereby you have to get detailed volume calculation, especially when you're doing 3D modeling. The LiDAR is very useful in that aspect. Then this is the last one, which is the safety and risk management. The safety and risk management, you are limited to where you can reach, especially when engaging yourself in the mining sector. You are limited to where you can reach. It's just like the masts. You see a lot of people climbing masts just to inspect a particular there's a wire that is not connected properly. But with drone, you can just send it up there with a drone with a very good camera resolution and that can zoom. It's not all drone that can zoom, so you should know this. There are drones specific for there are drones built for a specific purpose. All right, especially drones that can be able to zoom are mostly for inspection. Do you understand? Why drones with automatic and manual focus and automatic shutter are very good for mapping. You understand? And also embedded with GNSS and RTK. They are very good for mapping. And you have a lot of them like that. But a lot of people get confused. You get a drone that you see people using for content creation. You also want to use that for mapping. You're not just endangering your drone, but you're lacking, you lack in quality. The results and the reports you get from that drone is going to reduce in quality. All right. So for health and safety and safety and risk management, you can send this drone out there, especially in small holes or big holes. You can send it out there before you go in there to inspect to be sure if it is safe before you can go there. All right. So we have technical teams, especially when going to sites. Now, this is for those operating, uh, having a drone department. You should always have a drone pilot and a security team. It's not everywhere you go to that you just assume that the drone pilot is safe with the drone. So far, he has the drone with him, he's safe. You should always have a drone pilot with a security team. You should have a technical support engineer in case there's any glitch on site. And you should have compliance and safety officer. You should also have security and operators managers. We also have other team at Geoinfotech whereby we have those that does the data analysts and GIS specialists, the command operators, the drone maintainers, and the IT and network administrators. We also have the security operators, managers, and emergency response person. And this is me telling you areas you can fly and areas you cannot fly. In Nigeria, especially if you are common with the DJI, there are areas you can actually operate this drone. And this is, we have embedded on DJI stuff that you can't fly in restricted zone, especially when you're flying at close to airport. So anytime you're flying, always make sure you check the map, check the areas you're flying, and be sure that you are safe to fly within those regions. And this is also telling you you're not allowed to fly at military zones, government buildings, or villages without warning. Okay, especially airports, power plants, and prisons without warning. So, in as much that we are telling you that drones are useful in this sector, we should also let you know that there are some areas you are not meant to fly. Even if you are going to fly a drone there, you should also let the people around there know that you are coming to fly. Okay, and some drone will not even take off. Even if you get there, it won't even take off. So you should do your homework before going to site. Do a lot of homework before going to site. So in as much that this drone is very good, you can fly with this, you can do a lot of stuff, you can get a lot of data sets. Trust me, 95% of drone operation is done with planning. Telling you, 95% of drone operation is done with planning. You plan the areas you want to fly, you check the weather. That's the next one. This is me telling you also that before you fly, you check the direction at which you're flying at. It's also important, especially when you're flying with automated planning. You're flying autonomously. Okay, that is you flying without you controlling it manually. You've already set the mission there. You just tell the drone to go through this direction, go here, and all of that. You must always fly with the right direction. Okay, this is windy.com in case you want to check this out. And it gives you free access to check the weather for just 1 week. I think, yeah, for 5 days. Yeah. So it gives you the idea of the weather. So if you're going to fly, you should also check the weather. If this weather is good, you should also know what is the tallest building, tallest object around there. This is for safety. All right. You should also know the tallest buildings, tallest object around there. And you should also check if there is any prison, police, post, army barracks, and all of that. Trust me, you don't want to get your drone into all those guys. So you should do a lot of checking. A lot of maintenance with your drone is very, very important. Check your drone. And one last thing I will say, you should check the camera settings. Trust me, you can go ahead and fly your drone, but you might be flying and flying stuff without checking the results at which you're flying. You wasted a lot of time. And what we are bringing to you is time management, costs, and also it makes it give you quality results. So flying, check your drone, the hardware itself, check the settings of your drone, check the environment. That's your reconnaissance survey. Check the environment at which you want to fly. This gives you an idea of what is the tallest building around there, so you know the altitude at which you're flying at. Okay. You can also check environments if there's any airport, helipad around there, and also make sure you alert the aviation authorities. They will also guide you. Okay, alert the aviation authorities. They will guide you. Okay, and if you're having any issues with your drone, trust me, make sure you get a drone that has a return to home. there are a lot of drones out there without this functionality. Get a drone with return to home, and this is another result you get from drone. You can get this. These are changes to give you an idea of the elevation, okay, of that site. With this, you can understand the topography. You can understand what you can do with it. You can understand the flow and pattern around the site. And this is one analysis that you can implement and overlay on the Google Map or other software that gives you an idea. So this is a setback within a particular route. Okay, so I'll be displaying some of the results we get. Just a minute. All right, so there was a time we did a survey, and this was done recently with a drone. This was done recently with a drone, and just a minute. This was done recently with a drone, and most people there's a lot of difficulty when surveying indoor, and this is us trying to survey indoor, okay, on a site. All right. The challenge we faced here was a lot. Challenge we faced here was a lot, and this was us flying the Phantom. Okay, so and this was the results. The result actually came out well. We were able to calculate the volume of this material indoor. And trust me, you can't do this with just a drone and differential GPS. So the trick there is we have to use a total station. You can't do this with just a drone and a differential GPS. All right. And when doing this, you have to get something like a total station with, let me play this. Sorry for the glitch you're seeing there. So this was us trying to calculate indoor. We're able to delete some of the other data that are not necessary. That's the side walls and other things that are around it. So we're able to calculate the volume here without just measuring it with manuals and all of that. But another thing again is the more GCP, or shall I say, the more points you pick on site with your drone data, the more accurate your results will be. So we're able to use a surveying drone with a total station, and we also did a little bit of differential GPS to ensure accuracy and validation of the data sets. And with other photogrammetry software and remote sensing software, the more remote sensing software, we're able to calculate what we got here. All right, and this is I think this is for construction. Okay, I think this is for construction. Let me see if I can pull this up. All right, so for every project you survey on site, there are a lot of results you get. You don't just go ahead and just get your orthophoto, your TEM, your contour. No, you might go as well to get the pipeline that are there, the current features, their manholes, their routes, footpaths, and all of that to understand the full terrain of that site. And note that most construction sites, the results you get are sent to the town planners or developers or architects to be able to plan this site according to its use. Now, this is for construction, whereby we're able to get the topography. This was about 1,000 or 2,000, 1,000 hectares of land that was surveyed within, I think, less than a week or so. So surveyed less than a week. We try maintaining accuracy in, especially with the pixel, not only with the pixel, also the GCPs we are picking on site. So the accuracy, there's height for accuracy for vertical accuracy and there's horizontal accuracy. And we try maintaining less than 3 centimeters. All right. So you can see there are multiple factors, multiple layers here. We have the contour there. We have the GCP XYZ as well. We also have the river parts. So you should maximize the use of your drone on site. You don't just capture this guy. You can also extract features, automatic rasterization or vectorization of the site to get footpaths, to get road network, to get if there's any railway track, water body there, rivers and all of that. So this will help anybody trying to build a drainage around there and help anybody trying to build, okay, this is the best part for setting up residentials. This is the best part for setting up hotels and other commercial activities around the site. With this, you can get detailed information. And another thing that is most important within the drone industry that most people don't do is the classification of features around there. You can classify areas that are currently covered by vegetation. You can classify areas that are currently covered with existing settlements. You can classify areas with just roads. You can classify areas with forests and light vegetation. That is what other remote sensing software can do for you. All right, so this is me thanking you and appreciating you for joining us all the way, and I appreciate you for your time and attention. And we're getting more of you. Your questions, you can drop it on the comment section or you can send it. So I think the coordinator will explain much better on that. All right, thank you once again for having me.
Wow, that was a really, really insightful presentation by Mr. Dipote. Thank you, sir. Someone here asked a question. Before we move forward, we just want to address the person's question. So the person asked, the person asked if drone can be used in urban and regional planning. Can you answer that question for us, Mr. Dipote? Thank you, sir.
All right, thank you. So regarding drones in urban planning, there's a lot you can do with drones in urban planning. Number one, just the surveying aspect, the high resolution image you get from your drone data sets can give you an idea of what is already existing there and how you can plan further. Like I explained in the other video, okay, there's a lot of data sets you can see in that video, although they are in form of line, points, and polygon. But if you give an urban planner or town planner these data sets, they will be able to understand, okay, this area is slopey, this area is this, and this area is that, except you want to spend a lot of money in cuts and filling up the place and all of that. But with the current nature of the site, it can give you an idea of how you can channel your drainage. You understand? It can give you an idea on how you can zone a particular area. And infrastructure monitoring regarding the urban aspect, when you are developing the site, you can inspect the developments, the bridge, other utilities, electrical structures, and other structures on site. And also you can do this for site development and planning. You can analyze the topography and understand the terrain of that site. And also you can also do with GIS in urban planning, you can do what we call environmental impacts assessments. Okay. Environmental impact assessment can help you analyze the flood-prone areas, okay, and areas for deforestation, and also you can understand the population level currently on that site. And also you can do a lot of stuff regarding the traffic and transportation. So these are areas where drone can come in. Okay, also you can analyze, just like what happened recently at the Mokwa flood. Now let me show you a clip of the Mokwa flood recently, and I will give you a detail of how you see the usefulness of drone in Mokwa currently. Just a minute. So I'm going to be sharing my screen now. So you notice something. This was the project we did at the Mokwa flood, whereby we went to Kwara States, Niger States. It happened at Mokwa, and Mokwa to the airport was about almost 1 hour. And you see the flood that's occurred here recently, and a lot of damage was made with this. But if you have implemented drone, you will have saved a lot of lives with what just happened. And when we observed this, we calculated a lot, and we did a lot of survey, a lot of analysis. You can see the 3D model that we're able to get. Now, during the course of this flood, we were able to observe that the water had accumulated because of the source of where this flood was coming from. All right, let me pull this up just a minute. I think all right, just a minute. I'll be putting this up so that you can understand this one is a live project that happened recently within so sorry for what happened at Mokwa. And this one is more like a live project which Geoinfotech voluntarily took upon to survey, to understand the cause of the flood and the source of the flood, and also we're able to survey we're able to survey and understand what can be the solution. So this is what GIS can do for you. It can give you after results, before results, and after results, and current results. Okay, I'll be sharing my screen for the results we got on site and some of the reports we got on site as well. Okay, yes. So during the course of the whole survey, we were able to understand, we were able to ask a lot of questions from the indigents that, okay, what actually happened? And they told us that the flood came from not from River Niger, because you notice on that site, we have River Niger there, close to the village, and the water accumulated actually around there before the flood happened. And from this, the flood was coming from a local dam from the north. With this, we were able to survey that, yes, at, what made the water accumulate was because of the blockage we have here. Okay, because of the blockage we have here, the railway blocked the water from passing through. That's from the local dam. So it accumulated here for like days. After accumulating here, a day before the flood happened, rain fell there. All right, this was what made the water spill over and wash off to this site. This was what made the water spill over and wash off to the other side. You can see the damage up here, the level of flood, and we calculated the impact and the slope of, shall I say, the intense movement of this water from here. So because of the impact of water that fell over this railway, this place also opened. This was now what gave easy access for the water to flow through. And because of the full force of the water that came through from this side, that's what led to the devastation of the Mokwa flood. That's what actually led to the devastation of the Mokwa flood. And from the survey, you can see below here, you can see the water flowing from the north, from up, okay, flowing from up there, moving down like this is the railway side here. Okay, the water was flowing from here down like this, but it accumulated here for days, and because of so it created like a shall I say an artificial dam here. So because of the soil here was kind of weak, we observed that the soil here was very weak, and you see that the water force that spilled over was what made this place to open. And as this place opened, it made it easy for all the old water to flow through. And because of the intense movement of the water that came through, that's what washed a lot of buildings that were there. And we went ahead to calculate all the buildings that were affected. So with this, we calculated we observed the satellite imagery of a day before of that site when it was a norm. Okay, a day before, and we compared with the current situation. We digitized all the buildings that were there and compared to the buildings that were now. We saw that about 300 buildings, about 316 buildings were gone. So now imagine how many persons per buildings in that side. And we caught an average of person per building to be like 20 to 15 persons per building. Some you can get like 4, 5 because they're in the north. So we're able to calculate the slope of this side. Mokwa was actually lying on a slopy environment. Was actually lying on a slopy environment. And from there, we were able to know that, yes, the water was washing from there. You can see the damage, the impact of the damage is caused. It's washed off from there down to River Niger. So the force was coming from that hill. So with this, we didn't just only calculated the results, the extent, and we're like, okay, we are mourning them or what of that. We also did a solution. So from the survey we did here, we noticed that this place is actually best for creating a channel for drainage. If there's a channel for drainage along this side, it will limit the accumulation of water here. And if it limits the accumulation of water here, there is no way water will just come and give a lot of flood devastation around that area. So if they create a drainage channel from the local dam down to River Niger, trust me, there will be no issue here. And also with this result, they can also do proper planning. With this, they can do proper planning to avoid flood from happening in future. So I don't know if this has answered your question. Okay, thank you.
Thank you, Mr. Tintop. I'm very sure the person that asked the question will be more than satisfied. Um, we have some questions for you, just like 2 questions before we round up the webinar. And okay, before we take these 2 questions, to everyone in this webinar right now, we are going to be having this video on our YouTube channel, so you can watch after this season. So you can rewatch, you can share with friends. Yeah, so it will be available for you to watch. So we'll take the questions. So to our speaker, the question is, okay, if I'm just starting out, right, as maybe a drone pilot or somebody in construction, what is the most affordable way to begin using drones and drones for mining and construction projects? What's the most affordable way? You want to believe Geoinfotech has been into this field for a while now. We want to know, okay, somebody that is just getting into it, what's the most affordable way for them to start out with using drone?
Yeah, thanks for the question. So basically, if I understand you correctly, how do you get your feet wet and what's the cheapest way of doing it? To be honest with you, there's no really cheap way of accomplishing what we've gone over. What I would advise, or Geoinfotech would advise, you start off with the DJI Mavic 3 Enterprise, and that would run you. Don't quote me on cost because they change all the time. But just call Geoinfotech and they'll be able to give you the price of such. But just having the Mavic 3E, it's not going to cut it. You still have to you're going to capture the pictures, right? You're going to have to stitch them together. In other words, process them. So there's the software, the drone deploy of Pix 4D. So those are all the kind of things you have to take into consideration. But again, call up Geotech, send us a email or a WhatsApp message, and we'll be able to walk you through.
I wanted to throw more light on that actually. All right, so I will start with some of the equipment you can make use of. You can see it on my side here. You have the RTK module. This RTK module can work with we have this we have the Mavic Enterprise. For the Mavic Enterprise, you can make use of this guy for mapping, especially if you want to go with detailed mapping. Okay, that's for the Mavic Enterprise. This one is quite less expensive compared to the Matrix 40 because it has a lot of mapping in it. So any of the Mavic Enterprise, you can go with that. Okay, this is the Mavic Enterprise here. Okay, I think you to bring it out, you open it like this, and like this here. All right, so this is the Mavic Enterprise. We have the Matrix 40 and the Matrix 4A. You also have, anytime you're doing this survey, you don't just use this guy, or else you want to contact a surveyor, which is also important. You can get a surveyor, the RTK model. Okay, you can get an RTK model with the Mavic 3 Enterprise with that is the RTK model. You can be able to see it on the right here. Yeah, that's the RTK model. It connects to this guy to enhance the accuracy. But if you don't have the RTK model, you can go for a cheaper one. That's for the eye target. So this is the eye target P200. Okay, you can go with the eye target P200. It also has accuracy about centimeter level, like 1 to 2 centimeter level. All right, that's for the RTK. Then, but if you're buoyant enough, you can go for the Matrix 40, or you can go for the Matrix 350 or Matrix 400 that just came out. The Matrix 350 and 400 are quite expensive because you have to buy the payload separate. But the advantage to this is because you can attach other payload, because recently we are getting payload for geology, and that goes for the mining sector, whereby you can observe minerals beneath the ground surface. Okay, those are payload with electromagnetic, okay, radar aperture. Okay, those are payloads that has combination of those sensors, whereby it can read other magnetic interference beneath the surface to get results. So you don't have to go there physically. You can just send the drone there, observe the environment, study the result, and predict where you can get results for what you are actually aiming for. I hope this has answered your question. But if you want to also get prices on these, You can go to geoinfostore.com. You see a lot of software, a lot of hardware. You can get them there. Geoinfotech, geoinfostore, okay, .com, geoinfostore.com. Or you can go to the website geoinfotech.ng, then go to the store button. You get access to the geoinfostore.com. All right. I hope that has answered your question.
Yes, so thank you very much, Mr. Famiwa and Mr. Tope. We have one more question, and we've been talking about the drone capturing and making very detailed videos and taking pictures around the construction mining site. But our viewers would love to know what software tools do you recommend or would you recommend for processing and analyzing this drone data effectively? Softwares that you would recommend for them to
Yes,
process.
hi. Basically, the best software out there to process all the pictures, stitch them together, for you to get all the maps that Mr. Tokwe talked about, all the deliverables that Mr. Tokwe talked about, depending on what your client wants. Best out there, Pix 4D and Drone Deploy. You can't go wrong with either of those two software processing packages. That's it. Thank you.
Okay, thank you, Mr. Famiwa, for answering the question. This brings us to the end of today's webinar. I hope that you've been able to learn a lot because for me, I've been able to learn a lot actually. Um, okay, also, like I said before, this video will be available at your own disposal. Anytime you want to watch it, you can just head over to our YouTube channel and you find it there. Um, on this note, we say thank you all for being part of our webinar today. On behalf of Geoinfotech, we sincerely thank all our speakers for sharing such valuable insights. And to our Managing Director, Mr. Makinde Temitope, thank you for setting the tone with your visionary remarks. And to our main speaker, Mr. Famiwa, we truly appreciate the depth and clarity you brought to today's discussion from the real life applications, the future potentials of drone in these industries. To everyone, we hope that this session rather, has opened your mind to the many ways drone technology is driving transformation from site monitoring to volumetric surveys, safety checks to precision planning, everything all together. So thank you for your time. Thank you for your attention and questions. Your participation really made this webinar a success. So we already said that we'll share the recording and slides. Everything will be available. So please watch out, and would really love to have you in our webinars going forward. We're having more webinars, workshops, and would really love to have you there. Geoinfotech is up and out always for impact in tech field, always. So until next time, stay innovative, stay curious, stay safe, and have a great day. Once again, thank you for joining us today.